Now we move on to question number 8. Question number 8 is again on differentiation, and for this question is on rate of change. So point P lies on the curve y equals to kx squared over square root 2 minus x, where k itself is a constant. And the question tells us that at point P, the x coordinate is actually minus 2. So given that the gradient of the normal at P is 1 over 7, show that k equals to 4. So the first thing that we definitely have to do is to find dy dx. So let's find dy dx now. So we can see over here we have to use the quotient rule. Okay, the quotient law, So dy dx equals to, square the denominator. So when you take the square of the square root of 2 minus x, we get back 2 minus x. And bring the denominator up. And then we differentiate kx squared, we get 2kx. And then we keep kx squared. And then we differentiate the denominator. So we are going to differentiate square root 2 minus x. Okay? So that's what I will be doing. So this is actually d dx of bracket 2 minus x bracket to the power 1 over 2. So bring down the power 1 over 2. Subtract 1 from the power. So half minus 1 is minus 1 over 2. And then finally differentiate the inside, we get minus 1. So this is actually minus 1 over 2, 2 minus x, whole thing to the power of minus 1 over 2. So we have minus 1 over 2, 2 minus x to the power of minus 1 over 2. Okay? So what I've written below is the working so that you guys can see clearer. So this is equals to 2kx So what I'm going to do is I'm not going to skip step so that you all can see clearer. I'm going to write square root 2 minus x as bracket 2 minus x bracket to the power of 1 over 2, and then bracket 2kx bracket minus bracket kx squared bracket, and we have the rest over here. So what I'm going to do as per normal, we are going to take out the one with the negative exponent. So we're going to take out bracket 2 minus x bracket whole thing to the power of minus 1 over 2. We're going to take it out. So we're going to factor it out. And then whatever that is left inside will be 2 bracket 2 minus x. So if you find it difficult to actually factor out negative power, what I would suggest you to do is when you try to write the expression inside over here, and then when you're done, you multiply this back inside to make sure that you get back the numerator over here. So this will be 2kx, and then we have our plus kx squared over 2, because minus times minus plus kx squared times 1 over 2 is kx squared over 2. So this is over 2 minus x. Now we're going to bring down this 2 minus x whole thing to the power of minus 1 over 2 below to the denominator. So we get 2 minus x, 2kx plus kx squared over 2 over 2 minus x bracket whole thing to the power of 3 over 2. Because I bring it down, it becomes 2 minus x to the power of 1 over 2 times 2 minus x. So this is in the denominator. So the loss of indices, it means that half plus 1 is actually 3 over 2. So that's how I get the denominator over here. So we have our dy dx now. So at P, which is at x equals to minus 2, the gradient of the normal at P is 1 over 7, which means that the gradient of the tangent at P will be minus 7. Okay? Because if the gradient of normal at P equals to 1 over 7, right? Then we also know this, which is what we have learned. The gradient of normal at P times the gradient of tangent at P equals to minus 1. So this is 1 over 7 times gradient of tangent at P equals to minus 1, which means that the gradient of tangent, which is what dy dx is measuring, at P equals to minus 7. So what we're going to do now is at x equals to minus 2, dy dx equals to minus 7. Because the x coordinate of P is minus 2, so dy dx equals to minus 7. So substituting this value of x into dy dx, okay, into this expression over here, we get 2 minus minus 2, okay, and 2k2, right, plus k over 2 and then minus 2 whole thing square. This whole thing divided by 2 minus minus 2 whole thing to the power of 3 over 2. This is equals to minus 7. So this over here is 4 times 4k plus 4k over 2. So this whole thing divided by 4 to the power of 3 over 2 equals to minus 7. So the numerator evaluates to 16k plus 2k. Okay, so let's see. Sorry, give me a while. That is 2kx, 2 minus x. Yup. Okay. Let me see the working. Sorry, over here this is a minus. Okay, my apologies. So this means that it will be 4 times minus 4k. Okay, so correction. So in this case, it will be minus 16k plus 2k whole thing divided by 8, because 4 to the power of 3 over 2 is actually 8. So this equals to minus 7, which means that minus 14k equals to minus 56, which means that k equals to 4. And we have shown that k equals to 4 over here. So that's for 8 part I. So for 8 part II, the point P moves along the curve as seen over here. Now given that x is increasing at a rate of 0.9 units per second, which means that dx dt equals to 0.9, find the rate of change of OP square at the point x equals to 0.5. So OP over here is actually the distance. They're talking about the distance OP over here. And they want to find the rate of change of the distance OP, but square it at the point x equals to 0.5. So this question can seem to be very confusing for students. That's understandable. So let me work it out so that you all can understand what is 8II doing. So the distance OP, right? But we square it, okay? So let's say that this point P, okay, has the coordinate x, y, which means that the vertical distance over here, you can think of it as y, and the horizontal distance over here, you can think of it as x. So using Pythagoras theorem, the hypotenuse over here, the length OP, which is OP whole thing square is equals to x squared plus y squared. So here we are using the Pythagoras theorem. So this is equals to x squared, and we know that the curve is actually y equals to 4x squared over square root 2 minus x, because the equation of the curve was given here and we have shown that k equals to 4. So we put 4 inside, we get y equals to 4x squared over square root 2 minus x. Okay, so then this will be plus 4x squared over square root 2 minus x bracket whole thing squared, because it's y squared over here. So let's simplify this expression over here. This is actually x squared plus 16 x to the power of 4 over 2 minus x. So now we can differentiate OP squared with respect to x. So this gives us 2x plus, using the quotient law, so 2 minus x whole thing square, square the denominator, and I'm going to bring up the denominator, and I'm going to differentiate the numerator, and then minus, keep the numerator, differentiate the denominator. Okay, so this gives us 2x plus 128x cubed minus 64x to the power of 4 plus 16x to the power of 4 over 2 minus x whole thing square. So this is equals to 2x plus 128x cubed minus 48x to the power of 4 divided by 2 minus x whole thing square. And at x equals to 0.5, okay, which is what we are interested in, right? dOP square over dx. Okay, we're going to substitute x equals to 0.5 over here. Is actually 2 bracket 0.5 plus 128 bracket 0.5 cube minus 48 bracket 0.5 to the power of 4 divided by 2 minus 0.5 bracket square. So let me key this in my calculator. So we get that this is 61 over 9. Okay? So using the connected rate of change, right? dOP square over dt, which is what we want to find, right? The rate of change of OP square at the point x equals to 0.5. We can get dOP square over dt equals to dOP square over dx times dx dt. And we know that at x equals to 0.5, dOP square over dx gives us 61 over 9, which we have evaluated earlier. And dx dt is given by 0.9 by the question. So which means that this is actually equals to 61 over 9 times 9 over 10. So this gives us 61 over 10, which is equals to 6.1. Okay, so now we have our answer. We can complete the statement. The rate of change, okay, of OP square, the length OP square equals to 6.1 units per second. And we are done with this question over here on 8 part 2.